Hello everyone, my name is Richard Sundell and today I'll be giving a presentation on the filtration and purification process for water used in hemodialysis treatment. For the past 4.5 years, I've worked with a company called Fresenius Kidney Care as a biomedical equipment technician, and one of my main responsibilities was to maintain, disinfect, and repair the pre-treatment and reverse osmosis, also known as RO system, for use for water in the treatment of patients. The most important thing that we have to do is filter out the water and make sure it's as pure as possible, not only for the fact that a patient gets exposed to a lot of water, and you may wonder how much water. Now, the daily recommended serving for a person is roughly about a gallon for the average person. Now, for the average hemodialysis patient coming in for a treatment, that's usually between 3 to 4 hours. Typically, they're exposed to about 32 gallons of water. Now, not only is that a main reason why we have to make sure we filter out any of the chemical contaminants, just because of the sheer volume that they're exposed to, but also because we need to make sure that the prescription that we're providing them between their prescribed acid baths and the sodium bicarbonate that's mixed together with the Ultrapure water, to be able to make sure we're giving them the best prescription possible. Now, the first step when we're opening up a dialysis clinic is usually to look at the local water source. Typically, it's easy enough for anybody to find. Usually, you can just Google your local city or county and just find their .gov website. If you go on there, you can usually go into the utilities tab, look for the water and sewer section, and then be able to see the annual water report. Typically, that's usually drawn once a year. Sometimes in certain counties or certain cities, it's only mandated to draw once every 2 years. But at least this will give you a general idea of what is in your water and what additional things they're adding as far as like chlorine or chloramines to be able to help with disinfecting and to be able to make sure of the contaminants that you have in your water if you're curious about that. Then what we would usually do, we would take that in tandem with a sample that we would draw on site ourselves to send out for testing to find out slightly more scrupulous version of testing to see what we're dealing with, what contaminants are in the water, and what we need as far as filtration system for the clinic itself. Usually the first step in the process is to, depending on the water temperature coming in, usually we're looking at between 60 to 85 degrees is kind of our range. Anything too cold, we need a water heater, and anything too hot, we're usually going to need a water chiller. Florida, there are some areas that actually do need water chillers because the water temperature coming in is over the 85 degrees. Not super common, but it does happen. The next step in the process is a water softener. Now, in Florida, we have very hard water for the most part. So this usually means that we have high levels of calcium and magnesium in our water system. So what the softener does, it has a special resin inside of it that's charged almost every night, regenerated with salt water. Now, the salt water acts as basically a electric or a static battery. It attaches itself to this particular ion exchange resin, and as the water passes through, that electrical charge that's there from the sodium actually causes what's called an ion exchange, and it takes the calcium magnesium from the water and replaces it with salt. The calcium magnesium is left attached to the resin in the tank, and then when it regenerates later on that night, it dumps that calcium magnesium down the drain back into the sewer system or a natural water source. After that, we've got the carbon filtration. Carbon filtration is very important because we need to make sure we remove the chlorine and chloramines. They are able to pass through the RO system, the membrane that is filtered through. So we need to make sure it doesn't get to the patient, because if it gets to the patient, it's able to pass through to them, and it can cause a symptom known as or a effect known as hemolysis. Hemolysis actually causes the blood cells to burst, so it's extremely important that we remove that from the water. Now it passes through, and those tanks usually get filtered once or backwashed once every 2 nights to dump the chlorine and chloramines down the drain as well. The next step in that is to the actual RO system. Now, a reverse osmosis system puts the water under high pressure through a high-powered pump and forces it through a very tightly wound, semi-permeable membrane. It removes about 90 to 95% of any contaminants, so inorganics and organics, metal ions, chemical contaminants, as well as viruses, bacteria, and endotoxins. Endotoxins are actually dead bacteria that have burst. So it's able to make sure that it sends everything down the drain so nothing else gets its way to the patient. And that is my presentation. Thank you very much.